So multiplication operation. Now I wrote here one function x of t is e power minus at, e to the power of minus at into u of t. In these two functions are there. One function is exponential signal and another function is unit step function. Then the multiplication of these two. This exponential signal is e to the power of minus at, exponentially decaying function, because a value is negative. Now the graphical representation of e to the power of minus at with respect to time axis, this is negative time axis. E to the power of minus at exponentially decaying function. That exponentially decaying function starts from infinity onwards. It's like this, e power minus at. So here I am substituting some values here. In this time axis is changing from minus infinity to plus infinity. So initially I am substituting here t is a minus infinity. T is minus infinity this side. So in this substituted e power minus of minus infinity. E power minus of minus infinity is e power infinity. E to the power of infinity value is infinity value. So e to the power of infinity is infinity. Then at t tends to minus infinity, this amplitude is infinity amplitude here. And exactly at t is equal to 0 I am substituting now. So t is 0. If t is 0, then the function is e power 0. So e to the power of 0 is 1. So exactly at t is equal to 0, this amplitude is 1. And similarly, the t is positive now. T is positive, the final value is infinity value. So at t tends to infinity here, t is infinity. If t is infinity, then substitute here t is infinity, it becomes e to the power of minus infinity. E to the power of minus infinity value is 0. So this signal starts from infinity onwards. Infinity to it decreases like this up to 0. This complete function becomes 0 at t tends to infinity. This is exponentially decaying function, e to the power of minus at. Now one more function is there in this, that is u of t. So u of t just now we discussed here, unit step function. U of t explains the unit step function. This unit step function is defined from time is from 0 onwards. 0 onwards with constant amplitude. This amplitude is 1. This is u of t. Then one signal is required. X of t is equal to e power minus at into u of t. Multiplication of these two. Now multiplication of these two functions. In multiplication operation similar to the addition and subtraction, just perform multiplication of amplitudes in particular time period. See, time is less than the 0. This side, this function is e to the power of minus at, and this side, this function is here 0. So this into this. E power minus at into 0 is 0. And this side here, positive time axis. For positive time axis, this function is e to the power of minus at, and this function amplitude is 1. Then multiplication of these two is e to the power of minus at into 1. It gives it directly e to the power of minus at. So e to the power of minus at individual function is defined from minus infinity to plus infinity. This function is defined in particular time period with multiplication of these functions, that is unit step function. So then the resultant signal x of t is so negative time axis, this amplitude is 0, 0 into this value 0. So this side it is completely 0. And positive time axis, this function is e to the power of minus at, and this amplitude is 1. Multiplication of these two is e to the power of minus at. So exponential function is defined only positive time side. So this gives the e to the power of minus at into u of t. This u of t explains the time limits of the given function. The time limits of this function is from 0 to infinity, Negative time axis, this is not defined because this complete function is multiplied with u of t. Similarly, one more function, y of t is equal to e power at into u of t now. Here I wrote e power minus at, e to the power of minus at, exponentially decaying function, and here e to the power of at, this is exponentially increasing function because here a value is positive value is there. Then individual functions, e to the power of plus at, exponentially increasing function now, because if time is in minus infinity, time axis is minus infinity, e to the power of minus infinity is 0, then it starts from 0, exponentially increases. This amplitude is goes to infinity at t tends to infinity. This is e to the power of at, and this function is multiplied with again u of t now. U of t is unit step function. Unit step function, this is defined from time is from 0 to infinity with constant amplitude. This amplitude is 1. Then multiplication of these two. Individually this function is defined from minus infinity to plus infinity. If it is multiplied with u of t, now this complete function is defined only positive time side, negative time side amplitude becomes 0 here. So the resultant signal y of t is, the resultant signal y of t, for negative time axis it is not defined because 0 into something is 0, and this side 1 into e to the power of at, this becomes as it is, so e to the power of at. So this function is e to the power of at into u of t. These two functions are very important. According to the signals and systems analysis, exponential signal is one basic signal for all the systems here. Here two types of representations are there. One is exponentially decaying function and exponentially increasing function. If it is e power minus at into u of t, exponentially decaying function which is defined from 0 to infinity. Similarly, e to the power of at into u of t, then exponentially increasing function which is defined only positive time axis. So here u of t or u of t minus 1, some operations here. Here this function is multiplies. This function always explains the time limits of the given function. The time limits are either positive time axis or negative time axis or in particular time period. Everything is explained by this u of t representations only. Here I wrote u of t. Time limits of this function is 0 to infinity. That's why this complete function is defined from 0 to infinity only. This explains the multiplication operation. So addition, subtraction, multiplication of more than the one signals. And similarly we have another operation. That operation is a differentiation operation.